Hello guys, myself Balkrishna Pujari. Today we are learning how to solve 1D problem in Ansys, that is step bar. We are using the step bar today. Uh, the main aim of this experiment is stress and deflection analysis of beam using finite element package that we are using in the finite element package at Ansys 22 R1. This is a stepped bar. We have different three materials. Go for the Ansys Mechanical APDL launcher. Here we have to set the high performance computing setup. In that we have to use share memory, parallel and run. So window will be open. So in that first the preference, in that preference we have to select the static, structure one, preprocessor, element, add element. In that we have to add a beam, 2 node 188 element. Okay, and close. Now go for the material model, structure, linear, elastic, isotropic. So here you have to add the Young's modulus as EX and PRX5 as a Poisson's ratio. The three different material we have to add here. Material model 1, 2, 3. The first one will be 200 GPa, that is 2E5, and Poisson's ratio is 0.3. Now again we have to set as material model 2 as a ID2. In the new material we have to define the ID2 and we have to add the Young's modulus and Poisson's ratio as 1 e raised to 5, that is 100 GPa, and 0.3. And the third model ID number 3 as 70 GPa and Poisson's ratio is 0.3. Okay, so we have to close this one. Now go for the section, beam, common section. Here 3 stepped bar having a 3 different cross section, 3 different diameter of the total bar. So we have to set as a 3 ID, 3 set of this section. The first one, second one, third one as a 80, 60 and 45 diameter. First ID number 1 having a circular solid as 40 radius, and the second ID have 30 radius. Apply. And the third ID as 45 diameter, the radius is 22.5. Okay, now go for the modeling, create, key point, active CS. The blank will be indicate automatically to consider the key point number, so directly I will apply. The 0 set will be, and then in the X direction we have to set as 100 for the second point, and again we have to add in that 100, the 200, the third point, and last will be the 350. Okay, the first one will be the 100, second point for the 200, and third point is 150. We are adding in the 200, 150, that total 350. Now go for the line, straight line. First point to the second point, second key point to the third, third to the fourth. Okay. Now go for the meshing. First we have to set as mesh attribute. In that the default mesh, default attribute. So element will be the only one element we are considering, but the section will be the 3 sections that you have to set first. Go for the line, set, so select the first segment. Okay, and we have to add the number of element division. So I am considering here the 10, and now I have to go for the mesh attribute. For the second setting, so here I am selecting the material number 2 what we have set it, and the section number 2. Okay, now go for the set, line, set, and select the second segment. Okay, and this is also converted in the 10 number of parts, and I am meshing that the individual. Again go for the plot and draw the line and set as a mesh attribute for the third material and the third section. Select the last segment. Okay, this is, suppose I am dividing the number of parts as 15. Okay, and close the window. Now set this as mesh. The total mesh will be completed. Okay, close the window, sub window, and go for now the first segment, second segment, third segment we have meshed totally. Now go for the boundary conditions, the load, define load, apply, structure, displacement on node. So consider the first one, the fixed one, all degree of freedom. Okay, now apply the force at the last point, that is a x direction force in the positive direction. This is a 80 kilonewton. One side is a fixed one, and second is force applied at the last end, that is 80 kilonewton, that 80,000. Okay, now go for the solution, solve, current ls. Okay, and solution is done. So close the window. Now go for general post processor, plot result, counter plot, nodal solution. In that we have to consider DOF solution, in that displacement vector sum. Okay, so here you will check the values for the displacement. So here the animation we have to check. Before that we have to go for the size and shape we have to display. This is the actual model what we have drawn and what we are analyzing. Now go for the animation mode shape, in that DOF, deform plus undeform. So set here it is clearly visible deforming and undeforming of this object. One side is fixed, another force will be applying, for that it is expanding and contrasting. Okay, now we have to check the stress values in the isometric view. Now again checking the animation mode. Here we are considering the stress and von Mises stress. Okay, so here also the clearly visible the maximum stress and minimum stress where it will be occurring. So if we want to change the background color as a white, so this is the option. Now we have to check the animation. Okay, this is the analysis of the stepped bar. Okay, thank you.